Hello, today I'll be teaching you about completing the square. And you may be asking yourself, why do I need to learn about completing the square? Well, it's another way of solving for x in a quadratic equation, and sometimes it's easier and faster than using the quadratic formula. So, what is completing the square? Well, completing the square uses a square as a geometric proof to later substitute something within the actual equation that you're given. So let's look at the question x squared plus 4x plus 2 equaling 0. And let's draw out a square. And within the square, let's draw out a bigger square and a smaller square. This will also form two rectangles. I'm going to shade these rectangles orange and the bigger square blue and the smaller square pink. So let's say that this big square has a side length of x. And let's say that the orange width is half of the coefficient of the x, which in this case is 4. So this one, the side length here would be 2. Because 4 divided by 2 is 2. Sorry. So now we want to figure out the area of the giant square, or the square in total, right? And we can do this in two ways. One is that we add up all the sections within the square, so the blue region and the two orange regions and then the pink region, or we can add these two side lengths together and then multiply it by these side lengths added together, right? Knowing that the area of a rectangle is base times height, and we also should know that a square is also a type of rectangle, we can figure out this problem. So the area of this the blue region is x times x. The area of the orange region is 2x. And we can see that there's two orange regions. So then there would be two 2x's. And now we need to figure out this pink region. And we can see that this side length here is 2, and this side length here is also 2. So then this would be 2 squared. Or 2 times 2. And now this can equal this added together times this added together. So this would be x times 2 times this. This is not times. Sorry. This would be plus. This can also be simplified to being x squared plus 4x, because 2x plus 2x is also 2x's, and we can multiply these in to be 4x. So, and this will also be simplified to 4. But in the case of this problem, in this method, let's call this 2 squared. You'll later see why. And this equals x plus 2 squared. Okay. So what's what's missing from here? Wait, sorry. What's here that's missing from here? Well, we can see that there's an x squared in both of them. There's a 4x in both of them. But there's a 2 squared here, and there's not a 2 squared here. So I'm going to add a 2 squared. But we can't just add a 2 squared in without also subtracting a 2 squared. Right? So we'll also subtract a 2 squared from here. Because if we add something and we subtract something, the ultimate result will be 0. So we're essentially adding 0 to the problem. And adding 0 will not change the problem. we also have to remember this plus 2. And this equals 0. So, looking at this problem now, we see that these are exactly the same. And we just said earlier that x squared plus 4x plus 2 squared equals x plus 2 squared. Because these are both saying that these are the area of this giant square. And they both equal the area of the square, and they must be equal to each other. So, let's replace this x squared plus 4x plus 2 squared with x plus 2 squared. So, now looking at this problem, we can start trying to just do the algebra. So this would be x plus 2 squared. This would be minus 4, and this would be plus 2. And going through the steps, this will be x plus 2 squared minus 2 equaling 0. And now we can move the 2 to the other side, because ultimately we want to isolate this x here. So then this would be x plus 2 squared equaling 2. And now we can find the square root of both of these problems. So then this will be x plus 2 equaling plus or minus the square root of 2. And the reason we add the plus or minus is because when negative numbers are multiplied together, they are producing a positive number. And when two positive numbers are being multiplied together, they are also producing a positive number. So in the case of here, this could have two results equaling in 2. Right? So earlier we saw that x plus 2 was equaling 2. Well, x plus 2 squared was equaling 2. We can say that there is two solutions for this problem to here, which is the negative part, the negatives and the positive. So that's why we had to add the plus or minus. Now that we have this, we have to remove 2 from both sides to isolate the x. So this is your solution. X equaling plus or minus the square root of 2 minus 2. A lot of students have this problem of thinking that this belongs to both of them. So sometimes I would see students thinking that this would be the square root of 2 plus 2, or the square root of 2 minus 2, or the negative square root of 2 plus 2, because they would distribute the negatives. But that is not the case. The plus or minus only belongs to the square root of 2. So this is the way of solving for completing the square. So let's make the general formula. So let's say you have an ax squared plus bx plus c equaling 0. I like moving the c to the right side, but I didn't do it in this case because a lot of teachers like keeping it in the left. But in this case, I'll move it to the right. And if you don't want it to, you can always keep it on the left. So then this will be ax squared plus bx equaling negative c. So now we need to know something special about completing the square. It didn't show in this case, but when there is a coefficient on the x squared, it has to be factored out. So then this would be a open parentheses x squared plus bx. But because an a is factored out, this will be over a equaling negative c. Because if this is factored out, it has to be able to, when multiplied in using the foiling method, be the same as the previous step. Now we can start doing the square method. So now let's draw our square with one big square and one small square. This will be x, this will be x, and this will be half of the coefficient of the x. In this case, it would be b over 2a. So, we're going to need an x squared plus b over a plus b over a squared, which will equal x plus b over a squared. So, as you see, we kind of need this trend of adding this coefficient squared. Wait, sorry. This would be b over 2a squared. So it would be this coefficient divided by 2 squared. But we also need to remember when we add this to here, we also have to add it to here, or at least subtract it from here. So let's start the let's add it to both sides. So this would be a equaling x squared plus bx over a plus b over 2a squared. And this will equal negative c. And something about this solution is that when we're adding this to the right side, we have to remember we're not just adding this, because this is being multiplied by a. So we're actually adding a times b over 2a squared. So it will look something like this. Now, this might be getting a little bit more complicated, but as times go on and you keep doing these kinds of problems, these will get a lot simpler and a lot easier for you. But you should know that this is a little bit complicated, so don't feel bad or feel worried that you're for not understanding it fully right away. Honestly, I've been doing math for a while, and this is still something that I would have to draw out the geometric thing to help me memorize it. Right. So now doing this problem, we have to try this up. We have to substitute now. So this will be a x plus b over 2a. Sorry, I forgot to write it here. Squared equaling negative c plus a b squared over 4a squared, because this is also just saying that b over 2a is being multiplied by b over 2a. Now, this can be simplified to a x plus b over 2a squared equaling negative c plus b squared over 4a. Now let's divide a to both sides. This will be it will be x plus b over 2a all squared equaling negative c over a plus b squared over 4a squared. Now let's find the square root to both sides, because remember again, we're trying to figure out the x, so we will isolate it. So now this will be x plus b over 2a equaling the plus or minus b squared, the square root of b squared over 4a squared minus c over a. I just flipped these. Now we will have to subtract the b over 2a to both sides. This will be x equaling plus or minus b squared over 4a2 a squared minus c over a minus b over 2a. You don't need to remember this, or actually any of this, because you can just do the math yourself. All you need to remember is how to do the substitution and what to add and how to add them together, right? We need to add b over 2a squared to both sides, right? We need to add the b over 2a squared to within this equation to fit this property here. And when we add it inside of this parentheses, we will have to remember that the a is being multiplied into this. That is why we added a times b over 2a squared. Knowing how to do this and understanding this geometric proof will get you very far in doing this problem. And I'm pretty sure you'll be able to complete the problem yourself. So let's look at an example with real numbers with a coefficient on the x squared. So let's say there's 3 x squared plus, let's say 8 x plus 2, sure, equaling 0. I'm going to move the 2 to the right side. This is going to be 3x squared plus 8x equaling negative 2. I'm going to have to remove the 3 by factoring it out. So this will be 3x squared plus 8 over 3, over 3x equaling negative 2. Now I'm going to add half of this coefficient squared inside. So then this will be 3x squared plus 8 over 3x plus 8 over 6 squared equaling negative 2. And as a reminder, the 3 is being multiplied into this. So I'm going to multiply that too. Now, this will be simplified into x plus 8 over 6 squared. The 3 goes down as well. So, whatever is being squared is actually just going to be added together in this case. And if this value here is negative, then this value here will be negative. And this will equal negative 2 equaling, negative 2 plus 3, 64 over 36. Now this would be 3 x plus 8 over 6 squared equaling negative 2 plus 64 over 12. I'm gonna flip these from one another, and this will be 64 over 12 minus 2. And we can condense this one, or simplify this one, to 32 over 6 minus 2, which is also 16 over 3. Now, I will have to divide 3 to both sides. So I'm going to be using this one and this one from now on. So this will be x plus 8 over 6 squared equaling 16 over 9 minus 2 over 3. And now I need to square root both sides. So then this will be x plus 8 over 6 equaling plus or minus the square root of 16 over 9 minus 2 over 3. And now I need to subtract the 8 over 6 to both sides. And this will be x equaling plus or minus the square root of 16 over 9 minus 2 over 3 minus 8 over 6. I hope this all makes sense. And if you have any questions, feel free to leave a comment and I'll try to answer anything that might concern or be confuse you.